Hello everyone, today I'll be explaining how to derive the general surface area formula in terms of x. When we take a look at our textbook, on page 547, we can see the following expression. Now, to break this down for you guys, as many of you might already know, the sum tells us that we are going to be adding up many small pieces. The term f of x star j represents the height of the curve at some chosen point within the interval. The factor 2 pi times f of x star j is the circumference of the circle you get when that point on the curve is rotated around the x-axis. The square root of 1 plus f prime of x star j squared represents the length of the tiny slanted piece of the curve segment. Finally, delta x represents the small width of each subinterval. Now, a question that you guys might be asking yourself is, why do we use this factor exactly? Well, as the subinterval gets small, delta y over delta x is approximated by the derivative f prime of x star j. As a result, we are left with the square root of 1 plus f prime of x sub j star squared. Essentially, this whole expression is really saying, take the circumference of the circle at the point which the factor 2 pi times f of x star j and multiply by the slanted length of the curve segment, which is our factor. That product gives us the area of one thin band on the surface. Now, if you guys recall, the idea of a Riemann sum is that as we make the slices finer and finer, the sum becomes an exact integral. Taking that limit gives us the surface area formula in terms of x. Now, to see this in action, let's work through an example. If we let f of x equal x on the interval 0, 1, we can find the surface area formed by revolving this line segment about the x-axis. Now we need to find the derivative of f of x, which is 1. Here, this derivative means that the slope of the line is constant 1. The curve rises 1 unit in y for every 1 unit in x. We can now substitute this into our integrand, as well as replace f of x and f prime of x. And when we do so, we get 2 pi times x times the square root of 2. Now we want to set up the integral. S, which equals to the integral from 0 to 1 of 2 pi x root 2 dx. As you guys might already tell, the constants cancel out, leaving us with 2 pi root 2 times the integral from 0 to 1 of x dx. Now, the antiderivative of x is x squared over 2. Therefore, we can say that x squared over 2 evaluated from 0 to 1 equals to 1 over 2. Now, all we have to do is multiply to get our final answer. And when we do so, we get s, which equals to pi times root 2. Meaning that the exact surface area for this example is pi times the square root of 2.